Time for some e-learning with Miss Atkin. E-learning with Miss Atkin. E-learning with the puppy. E-learning with Miss Atkin. Yeah. What's up, scholars? Today we're talking about section 11.4, arc length and sector area. Now remember, an arc is some chunk of the edge of a circle. There's an arc, and let's say that arc came off of this central angle. We would know how to find the measure of that arc in degrees, but how long is it? Right? Because if we had another circle and we used a continued line, this arc would have the same measure in degrees as the smaller one, but the one on the outside is clearly longer. So we have to have a way to measure the arc length. And now a sector area is going to be an area, but the sector is going to be some slice of this circle. Like a slice of pizza would be a sector. Alright, cool. Let's do some definitions first. So to talk about arc length and sector area, we need to know the area of a circle and circumference, because the area of a sector is related to the area of a circle, and the arc length is related to the circumference. Great. So let's start with one that you've been known for a long time. Area of a circle. What does an area of a circle look like? Well, it's just how much space does that circle take up? And its formula is pi r squared, where r is the what? The radius. Now the area of a sector, what does that look like? Well, that's just a slice of the pie. And we recall that the measure of this arc is some amount of degrees. Okay? We're going to call that measure theta. It will be the measure of that arc. So the area of the sector, they're fighting in the background. Sorry about that. Let's see if we can make it through this here. Oh, no. Area of the sector is going to be that number of degrees, however big that arc is, that theta, that measure here, divided by 360 times pi r squared. Sorry about that minor interruption. Anyway, circumference. What's your circumference? Well, it's the distance around a circle, or the length of that line that we drew. Length of circle line. It's kind of a weird way to say that, but that's what I'm saying. The distance all the way around the circle. And we know the circumference is 2 pi r. Again, r is the radius. Now our arc length is not the distance all the way around a circle, it's just the distance, well, one little part of it. Let's call that AB. And let's give it its central angle there. So the arc length doesn't have a spell letter, which we will denote as AB with the arc symbol on top, but no M in front. If we put the M in front, then we just want the measure in degrees. But here we want to know how long is that line right here. So that arc length is going to be related to the degree measure, which again we called theta. Theta, Greek letter. Whoa, sorry. Children, leave it. Bean, leave it. Oh, the babies. The arc length is going to be that theta measure, that degree measure, divided by 360 times the circumference, 2 pi r. 2 pi r. fabulous. You guys are doing great. You're doing better than my animals. That's wonderful. And my ability to keep this paper straight. You're doing great. You know what time it is? Example time. Alright, we've got 2 examples here. We've got a circle here with a radius of 6 inches and a central angle that is 80 degrees. So let's find its arc length and sector area. So the arc length, AB, is going to be equal to the degree measure of this arc, which is the same as its central angle. So that's also 80 degrees. So that 80 degrees divided by 360 times 2 times pi times our radius, which is 6 inches. Time to break out the old calculator. 80 divided by 360 is 0.22222 repeating, or 2/9. 2/9 times 2 pi times 6. Let's multiply the 2 and the 6 and get over. 2/9 times 12 is going to give us 2 repeating pi inches. And you can actually leave your answer like this. You don't have to type in times 3.14. It's really preferable if you don't. It is a more exact answer if you leave pi in the answer. So, as math magicians, we like to be as exact as possible. That'll be our answer. 2.6 repeating pi inches. Cool. Sector area. The sector area is going to be, I cut you off a little bit. That same theta divided by 360. So 80 divided by 360, which we already reduced to 2/9, times pi r squared this time. Pi times our radius squared. So we'll get 2/9 times pi times 6 squared. We know 6 squared is 36. So we're doing 2/9 times 36, and we get 8. 2/9 times 36 squared is 36, is 8. 8 pi inches squared. Make sure you got a squared there, because we squared 6 and the inches. And its area, which is always squared. Alright, cool. Easy peasy lemon squeezy, let's do it again. We're going to find the arc length for CD this time. The measure of that arc is the same as its central angle, which is 100 degrees. So we've got 100 over 360 times 2 times pi times 4 centimeters. So 100 divided by 360 is another not fun decimal. 100 divided by 360. 0.27 repeating. You know what? I don't like this. Let's just multiply all the numerators, and then we'll divide by 360 in the end. So we have 100 times 2 times 4. 100 times 2 times 4 is 800 divided by 360. 360, because I did 100 times 2, which is 200 times 4 is 800 divided by 360 is 0.2 repeating centimeters. Oh, pi! I forgot my pi in there. Much better. 2.2 pi. 2.2 repeating pi centimeters. And our area is going to be that same ratio, 100 over 36, 360, times pi times our radius, which is 4 centimeters squared. We know 4 squared is 16, so we'll do 16 times 100 divided by 36. 16 times 100 divided by 360 is 4.4 repeating pi centimeters squared is our area. Wunderbar! You're doing great, everyone! Alright, let's kick it up a notch, shall we? Yeah, let's do some trickier ones. Alright, our first trickier example, we're going to find the circumference, the distance all the way around this circle. We know that this arc has a length of 4.6 meters and a central angle of 72 degrees. We're going to find the circumference. Well, we're given the arc length. Let's remind ourselves what that formula was. Arc length was the central angle over 360 times our circumference, right? Because 2 pi r is our circumference. So that actually makes this problem not too bad. We know the arc length is 4.6 meters. Length 72 degrees over 360. We can put a variable c here, which is our circumference. 2 pi r is the circumference. Excuse me. Okay, so then how do we get this c by itself? It's being multiplied by refraction. So we can multiply both sides by the reciprocal, and that would cancel out. Alright, 360's cancel, the 72's cancel. We'll have c by itself, so we need to do 360 times 4.6 divided by 70. 360 times 4.6 divided by 72, not 42. 360 times 4.6 divided by 72 equals 23. 23, what are our units? Meters. It's a big circle. Circumference is 23 meters. Awesome. Let's kick it up another notch. So this time we've got a circle with a radius of 18 inches and an arc length of 30 inches. And we're going to find the measure of that arc, meaning in degrees, which will be the same as this central angle. So the measure of that arc in degrees is the same as its central angle. We could call that x. That's really what we're looking for. X. Okay, again, we're given arc length. Let's write out what that equation is. The arc length of CD is equal to the measure of that arc, which is the same as the measure of its central angle, which is the thing we don't know, divided by 360 times 2 times pi times the radius, which is 18 inches. We know the arc length is 30, so we really have 30 equals x over 360 times, let's just do this quickly, 2 times pi times 18 is going to be 36 pi inches. Alright, we got to get this x by itself. Okay. So, what are we going to do, guys? What are we going to do? Let's divide both sides by 36 pi, so at least that part cancels out. 36 pi. Bye. We still have our inches, of course. And now for this question, I'm going to break what I write our answer as a decimal, because now we're dividing by pi. Ugh, I don't want to have pi in a denominator. So let's do 30 divided by 36 times pi. So we need 30 divided by 36 times pi. Let me just double check that. It should be a decimal for sure. 36 times pi. Okay, cool. We should get 0.265. Let's keep a couple decimals, and then we'll just in the end. These canceled out. We still have x inches over 360. We're very close. Let's just multiply both sides by 360. So these cancel out. So we'll be solving for our x in inches here and get 95.5. We're not in inches anymore. That doesn't make any sense. The measure of an arc is in degrees. Units mean nothing to me. They mean nothing. Goodbye, inches. Good catch. Good catch. We're really talking about degrees here. Much better. 95.5 degrees is the central angle, which is the same as the measure of the arc. Wunderbar. Alright, there are 2 more questions on the blank notes that I'm gonna give you as bonus. If you can work out one of those questions, you'll get bonus. If you can work out both of those questions, you'll get double bonus. So the bonus is the last 2 questions on the notes. Hot diggity dog. Let's get ourselves some bonus points, kids. Sounds great. Alright, scholars. That's it for this section. You've done an amazing job. You are almost to the end. Did you know that? Are you counting down? Because you're doing a great job. Just power through this last little chunk. Alright, I love you. I'll see you next time. Peace.